So we're going to use the ratio test again to find the radius and center and interval of convergence. This time we're looking at this series, a little bit more complex. So we're going to start with the ratio test. And so because we're looking at the ratio test, we could ignore the alternating portion of this. And so we're going to look at the n plus first term. And we're going to have n plus 1 times 9 to the n plus 1, all over the same function. Well, instead of writing this down, I'm going to go right to the copy.flop stage. So that's now written here. And so as n gets very, very big, n plus 1 and n both go to 1. And 9 to the n times 9 cancels, leaving a 9 in the denominator. Similarly, in the numerator, we have an x minus 4 to the n, canceling with x minus 4 to the n. What's left is the limit as n approaches infinity, and we'll have to write that each time to get full credit. Well, this 1 to the power of x minus 4 didn't cancel, so we have x minus 4 in the numerator, and we just have a 9 that didn't cancel out in the denominator. Absolute value of all this is less than 1. And so that means that x minus 4 over 9 is less than 1, but it's also greater than negative 1. Because of the absolute value signs. So multiplying everything by 9, we really have x minus 4 less than 9, which is greater than negative 9. Adding 4. X must be between 13 and 5. So from here you can see that our radius and our center, those can be calculated easily. Halfway between 13 and 9, the average is the center. 13 plus 5 over 2 is 18 over 2 is 9. So our center is 9. And our radius will be 4. Now, in order to find the interval of convergence, we're going to have to test our endpoints of 5 and 13 into the original series, including the alternating nature. So as we look at this original series, with 5 plugged in for x, we have 5 minus 4 to the n, and we have an alternating series. So we really have negative 1 to the n plus 1. Well, 5 minus 4 is 1, so I really have 1 over 9 to the n, and then I have an additional n in the denominator. So as I look at this, I have 1/9 to the n. This is definitely geometric and would converge, but I also have this n down here, which will likely also make it converge, but let's just do the ratio test to make sure. Since it's the ratio test, we could ignore the alternating nature. Got that crossed out. 9 to the n plus 1 in the denominator and 9 to the n. This is going to cancel and that's going to cancel, and we're going to have just 1 9 in the denominator left. This n should have been a 1, so that cancels out. And this n plus 1 and this n become infinity, or become 1 as both goes to infinity. So now we're really looking at the limit as n approaches infinity of 1 over 9. Absolute value of that is that less than 1. Well, I see here that I've made an error. You may have seen it before. Negative 9 plus 4 is negative 5. So when I plug a negative 5 in, then here we have not 1 over 9, but negative 9 over 9, which is significantly different. So as I fix this, this is what our series looks like. It looks like it alternates. But as we take a closer look and write down for n equals 1, 2, and 3, we're going to have negative 1, we're going to have 1 over n, where n is 1, times negative 1. Then when n is 2, this second term becomes positive, and the first term becomes negative. Negative a half, negative a third. This does not alternate. And therefore, by p-series, this endpoint diverges. So we're going to leave this symbol just like you see it. And now we're going to check the endpoint when x equals 13. We'll rewrite this for that. And now we have 13 minus 4 is 9 to the n. Same exact thing, numerator and denominator. Those are going to cancel out exactly. And we really have the series negative 1 to the n plus 1 all over n. And this will alternate. We'll have, when n is 1, 1 over 1 minus 1 half, plus 1/3. And so at this endpoint of x equals 13, we converge. And therefore we need to add or equal to, and so our interval of convergence includes 13 but does not include 5. Again, our center was still, and our radius was still 9 and 4. But the interval of convergence is the hardest to check because we have to check our endpoints of negative 5 and 13.